You know, there is this wonderfully bizarre story from the writer Lewis Carroll, the guy who wrote Alice in Wonderland, that it perfectly captures a trap we all kind of fall into when we try to understand the world.
Oh, right. The map makers.
Yeah, exactly. So in one of his lesser-known books, he writes about this fictional society of map makers, and they become so utterly obsessed with accuracy that they decide to create a map of their country on a scale of 1 mile to 1 mile.
Which, I mean, logically, that would just be a life-size one-to-one replica of the entire nation.
Right. And that is exactly what they built. But when they actually tried to unroll this masterpiece, the local farmers revolted.
Because it would cover the crops.
Exactly. They realized this massive sheet of paper would just cover the entire country and block out the sun. So the map makers gave up and ended up just using the country itself as its own map.
It's a great analogy.
It really is. The takeaway is pretty profound, I think. If you try to take in absolutely every single detail of reality, you just end up in the dark. Like trying to track every single cargo ship, every tariff, every currency fluctuation to understand the global economy, it's impossible.
Yeah, taking account of everything means you ultimately understand nothing. You just get lost. And that is why we have to rely on mental models. Economic theory often gets criticized for, doing a bit of violence to reality by simplifying these really complex human behaviors into abstract concepts.
Right.
But filtering out all that noise is really the only way to spot the massive tectonic shifts that actually change history.
Spotting those underlying patterns is our mission for you today. We are going straight into part 3 of the source material, Understanding Globalization's Changes. We are looking at quintessential globalization economics.
The really foundational stuff.
Exactly. We are going to look at just a few foundational mental models to completely decode the last 200 years of human history. Our goal is accounting for globalization's changed impact, basically tracing how the world shifted from the Great Divergence of the 19th century, where the West pulled massively ahead, to the Great Convergence that's, unfolding around us right now.
Which is a huge shift.
Massive. But to figure out how the global economy literally reshaped the Earth, we have to start at the absolute baseline. Like, before we get to supply chains or AI, we have to ask why nations even bother trading at all.
Right, and the underlying engine there is David Ricardo's concept of comparative advantage. But rather than diving into abstract 19th century trade theory, we can look at how this operates in the real world. At its core, international trade often functions a lot like geographical arbitrage.
Yeah, and the sources give this amazing example of the Swiss-Italian smuggling ring of the 1950s. It's the perfect illustration.
Oh, it really is.
Right after World War II, a lot of European currencies, including the Italian lira, were heavily restricted. They were basically unconvertible outside their own borders because, well, governments were desperately trying to hoard hard currency for essential reconstruction.
Yeah, so if you wanted to do business across the border, you pretty much had to resort to barter.
Which seems crazy for the 1950s. But this created a very specific economic pressure between Switzerland and Italy.
Right, because northern Italy had the climate and the infrastructure to grow rice very efficiently. Tobacco, on the other hand, is a tropical plant. It doesn't grow well in the Alps at all.
Not exactly tobacco country.
No, exactly. But the Swiss franc was one of the few strong, freely convertible currencies left in Europe. So Swiss merchants could easily use their francs to buy cheap tobacco in dollars from Latin America, ship it up the Rhine River, and just stage it right at the Italian border.
And meanwhile, the Italian government maintained this strict monopoly on tobacco and severely restricted legal imports just to save their scarce dollars for things like fuel and machinery.
Right, and the domestic result of that was entirely predictable. Inside Italy, cigarettes were incredibly expensive, while domestically grown rice was relatively cheap.
And across the border in Switzerland, cigarettes were cheap and rice was expensive.
Exactly. And this is where the mathematical reality of comparative advantage kicks in, even in a black market. According to the source material, a Swiss smuggler could buy 100 kilos of cigarettes for 2,000 Swiss francs.
Okay.
And they would hire couriers to just carry that tobacco over the Alps into Italy. They obviously couldn't sell at the official Italian retail price.
Yeah.
But on the black market, they could trade those 100 kilos of cigarettes for 75 kilos of Italian rice.
So just a pure barter exchange.
Pure barter. Then they bring that 75 kilos of rice back to Switzerland, where rice commands a huge premium, and sell it for 30 francs a kilo. That totals 2,250 francs.
Wow.
Yeah. The Swiss smuggling operation turns a 2,000 franc investment into 2,250 francs just by moving goods across a line on a map.
That's incredible. But the Italians on the other side of the border also walked away wealthier in terms of purchasing power, right?
Absolutely.
Because they got 100 kilos of cigarettes for an effective cost of 7.5 million lira instead of the 10 million lira it would have cost them through the state monopoly. Both sides basically bought low and sold high simply by exploiting the differing domestic prices.
Yeah, it is essentially legalized smuggling. Well, or actual smuggling in this case.
Yeah.
But when you legitimize that dynamic on a national scale, it fundamentally alters domestic production. We can see this really clearly in Meiji Japan between 1850 and 1870.
Right, because Japan had enforced centuries of strict isolation, so their domestic prices were completely disconnected from the rest of the world.
Exactly. So when they suddenly opened to global trade, they simply exported what was cheap domestically and imported what was cheaper abroad.
And the historical records show they exported massive amounts of silk and silkworm eggs.
Yeah, because their pre-trade prices for those items were incredibly low compared to European markets.
And in return, they imported cotton yarn, which was being mass-produced in Western factories way cheaper than Japan could make it by hand.
Right. And the economic impact was immediate. The prices of Japanese exports rose to meet international levels, which richly rewarded their most productive agricultural sectors. Simultaneously, the prices of their imports fell, delivering this massive boost in purchasing power to Japanese consumers.
So everybody wins.
Pretty much. This basic reallocation of resources, all based on comparative advantage, boosted Japanese average incomes by an estimated 9% in a very short period.
Okay, but I have to pause and challenge the underlying premise here for a second.
Sure.
If this buy low, sell high arbitrage is such a magical wealth creator, why didn't Meiji Japan instantly become as rich as Great Britain? Like, if trade intrinsically boosts average productivity everywhere it happens, how do we explain the massive, persistent inequalities we see globally?
That's the big question.
Yeah. Why did the wealth pool in a few specific Western capitals instead of spreading evenly across all trading nations?
So, that paradox requires a totally different mental model to untangle. It's called the New Economic Geography, or NEG. Comparative advantage explains why trade happens, but NEG explains the riddle of uneven spatial development.
Right.
It answers why we have hyper-dense megacities and why the G7 nations managed to hold such an outsized share of global wealth for over a century. The model basically posits a constant tug-of-war between two opposing forces that dictate where human beings and businesses locate.
Okay, so you have dispersion forces and agglomeration forces.
Exactly.
Dispersion forces are the factors that push economic activity apart. Like, high wages in an industrialized city might push a factory to relocate to a rural area just to save on labor costs.
Right.
Or intense local competition might force a new business to set up shop in an underserved town just to find a customer base that isn't already saturated.
Yeah, that's dispersion. But on the other side of the ledger, you have agglomeration forces pulling things together into dense clusters. And this operates on a principle of circular causality.
Circular causality.
Yeah, firms desperately want to be near their suppliers to cut down on transportation costs and lead times. They also want to be near their largest customer bases to boost sales. Consequently, customers migrate to where the businesses are, and businesses migrate to where the customers are.
Okay, but if that is the case, the falling cost of transportation should logically destroy those clusters, shouldn't it?
You would think so.
Yeah, because if shipping gets dirt cheap, which it obviously did with the invention of the steamship and the railroad factories, shouldn't need to pay exorbitant London or New York rents to be near their customers. They should be able to just scatter across the globe, chase the absolute lowest wages, and just ship their products back.
That assumption seems completely rational, but the model reveals a phenomenon called the home market magnification effect.
Which is?
When trade costs fall, firms actually become more footloose, and the agglomeration effect gets intensely magnified. Think about it. When shipping costs are high, local markets are protected.
Oh, I see.
A factory in Manchester doesn't have to worry about a competitor in London because the sheer cost of moving goods between the two cities acts as a protective tariff.
So the high shipping cost basically provides a buffer for inefficiency.
Exactly. And it's exactly the opposite of what intuition suggests happens when that buffer disappears. When trade costs drop close to zero, a London firm can easily sell in Manchester. Competition becomes fierce, margins become razor thin.
So they can't hide anymore.
Right. Firms can no longer afford to be isolated. They need every single localized advantage they can get to survive. They need to be across the street from the best specialized suppliers, the most advanced machinery repairmen, the deepest pools of skilled labor.
Wow.
Because they aren't shielded by shipping costs anymore, it takes a much larger, more concentrated movement of firms clustering together to find a new competitive equilibrium. Paradoxically, as distance matters less for shipping physical goods, economic activity clusters more.
That is so counterintuitive, but it makes total sense. And it isn't just physical goods and supply chains clustering, right? It is human knowledge. The sources bring in Paul Romer's endogenous growth theory to explain this.
Yes, this is crucial.
Like Isaac Newton famously said that if he had seen further, it was only by standing on the shoulders of giants. In economics, every new innovation creates a spillover. It generates ambient knowledge that makes the next innovation cheaper, faster, and easier to discover.
Exactly. Knowledge is a completely unique type of capital. Think about physical capital. If a factory manager buys a worker a physical hammer, that worker's productivity goes up. If they buy a second hammer, productivity goes up slightly less. By the time they buy the 10th hammer, it provides absolutely zero additional benefit.
Right, because you only have two hands.
Exactly. Physical capital always suffers from diminishing returns. But knowledge operates on exponential returns. Once an engineer invents a more efficient way to organize an assembly line, that blueprint doesn't degrade when it gets used.
But the catch is that knowledge, unlike a physical product, has a spatial constraint. You cannot easily stand on a giant's shoulders if that giant is working in a laboratory on another continent.
Not historically, anyway.
Right. Historically, knowledge spillovers were incredibly localized. You had to be in the same room, or at least the same neighborhood, to catch the sparks of a new idea.
And applying these agglomeration forces and localized knowledge spillovers to the 19th century explains the Great Divergence perfectly. In 1820, before the Steam Revolution, China alone accounted for roughly 33% of world GDP.
33%.
Yeah, and India's economy was as massive as all the North Atlantic economies combined.
Okay, so if agglomeration theory simply says the biggest market acts as the strongest magnet, the Industrial Revolution should have centralized in Asia. The ancient seven should have dominated the global economy. Instead, the G7 became the wealthy core, and places like India and China actually deindustrialized over the following century.
Well, European nations absolutely utilized political and military imperialism to force this outcome. They had a massive military edge honed by centuries of continuous continental warfare.
Right.
Britain actively suppressed colonial industry, going so far as to literally forbid the export of textile machinery just to keep a monopoly on production.
Plus, physical geography mattered too. Like the Himalayas acted as this huge barrier between India and China, whereas the Atlantic Ocean became a connective highway for European and American markets.
Exactly. But the underlying economic engine that sustained this dominance that made it permanent was those localized knowledge spillovers.
A self-sustaining furnace of innovation. As the steamship radically dropped the cost of moving goods, industry began to cluster in the global north.
And because the factories clustered in the north, the smartest engineers, financiers, and inventors migrated there as well. The knowledge spillovers were basically trapped in places like London, Manchester, and eventually New York. The north ignited this compounding cycle of modern growth, and the global south, which had been systematically stripped of its nascent industries, lost its capacity to generate those spillovers. They were locked out of the feedback loop entirely.
Ed Glazer's urbanization theory actually mirrors this perfectly on a micro level. People form dense, expensive cities for the exact same reason factories form clusters, to save on communication costs.
Right, you get smarter by hanging around other smart people.
Yeah, the text uses modern Bangalore as an example. IT startups cluster in these incredibly congested areas of India because founders need to literally bump into each other in cafes to share unwritten code solutions or, gossip about which venture capital firms are writing checks.
Exactly. That historical period, what economists call the first unbundling, was driven entirely by the falling cost of moving goods. It caused industry and knowledge to cluster in the north, forging massive global inequality.
So if the first unbundling was caused by cheap freight, we have to look at what happens when the internet makes moving ideas cheaper than moving goods. This brings us to the information and communication technology boom.
The ICT revolution.
Right. And with it, the second unbundling. To decode how this caused the modern Great Convergence, the text introduces the TOSP framework. We need to clearly define what tasks, occupations, stages, and product actually mean in a manufacturing context.
Yeah, this is a great framework. Think of a complex product, like a car. Building that product requires multiple distinct stages of manufacturing. You're casting the engine block, assembling the chassis, wiring the electronics.
Right.
Each of those stages employs various occupations: welders, electrical engineers, quality inspectors. Finally, every occupation is essentially just a bundle of specific tasks. A welder's tasks might involve reading a blueprint, calibrating a torch, and physically applying a weld.
Which goes all the way back to Adam Smith. He recognized the power of breaking down tasks way back in 1776 with his famous pin factory observation.
Oh, yeah, the classic example.
Yeah. He noted that a single blacksmith trying to make a pin from start to finish, drawing the wire, cutting it, pointing it, attaching the head, might struggle to make 20 pins in a day.
Which is terrible productivity.
Exactly. But if you fractionalize the process, splitting it into highly specialized tasks performed by 10 different workers, they could collectively produce 48,000 pins a day.
Right. Fractionalization unleashes immense efficiency, but it creates a massive new hurdle, which is coordination costs. You now have to manage 10 specialized workers and ensure the wire cutter is keeping the exact pace required by the pinhead maker.
Right.
When we look at the modern ICT revolution, we have to recognize that technology impacts these coordination costs in two completely different, sometimes opposing ways.
Meaning, not all tech does the same thing to a supply chain.
Exactly. Broadly, ICT is divided into coordination technology and information technology. Coordination technology, or CT, includes telecommunications, email, global project management software. CT drastically lowers the cost of managing people who are physically far away.
Okay, so that pushes things apart.
Right, this heavily favors separating the stages of production. It makes global offshoring viable because a manager in Detroit can easily coordinate a chassis assembly stage in Mexico.
But information technology, or IT, functions entirely differently. IT includes industrial automation, robotics, advanced machining. IT actually favors keeping things at home. It consolidates tasks.
Yes.
It reduces the need for fractionalization because a single advanced robot can now perform the work of 10 specialized human hands.
The Greenville, South Carolina fuel injector plant mentioned in the sources highlights this bifurcation perfectly. On the factory floor, you have a manual worker whose primary task is pushing a button to weld a cap onto a part. She earns roughly $13 an hour.
Okay.
Her job requires minimal specialized skill, and her immediate threat is not a lower-wage worker in Shanghai. Her threat is an IT-driven robot designed in America that can push that button 20 times faster.
Wow. And sitting in that exact same factory is a highly skilled technician operating a $500,000 computer numerical control, or CNC machine that mills engine valves to microscopic tolerances, and he earns $30 an hour.
That's exactly.
So IT is basically hollowing out the middle of the workforce. It automates the routine, fractionalized tasks, while placing a massive premium on the human capital required to program and maintain the advanced technology.
And when multinational firms analyze this landscape to decide where to locate their production stages, they face a complex mathematical tipping point dictated by what economists call convex coordination costs.
Right. Let's unpack that.
Imagine a manufacturing process with 6 distinct stages. If a company keeps all 6 stages in their home country, cross-border communication costs are 0.
But if they decide to offshore just one stage to a cheaper country, that single offshore team now has to maintain communication with the 5 stages still operating back home. That creates 5 complex cross-border communication links.
Right. And if the firm offshores 2 stages, those 2 offshore teams have to communicate with the 4 remaining onshore teams. That requires 8 cross-border links.
Okay, the math is scaling up fast.
It is. If they offshore 3 stages, the complexity hits its absolute maximum. 3 offshore teams coordinating with 3 onshore teams creates 9 separate international communication links.
So the complexity explodes the more you divide it, but the math flips if you push past the middle, right? Like if a company offshores 4 of the 6 stages, the coordination costs actually begin to drop back down to 8 links.
Yes.
And if they offshore 5 stages, it drops back down to 5 links.
Because the bulk of the production cluster has moved. The offshore stages are mostly communicating locally with each other within the new host country. This mathematical curve creates a phenomenon known as offshore overshooting.
Offshore overshooting.
Right, because the coordination costs peak so severely in the middle, firms hesitate to offshore just 1 or 2 pieces of a complex product. But once coordination technology makes it cheap enough to cross that threshold, they don't just move one piece, they offshore the entire manufacturing cluster to avoid the nightmare of managing a supply chain split perfectly down the middle.
Which gives us the blueprint for the Great Convergence. This explains why the global south suddenly began industrializing at a blistering, historically unprecedented pace in the late 20th century. G7 corporations didn't just offshore basic labor.
No, they didn't.
They moved entire clusters of production, injecting their highly advanced proprietary know-how directly into southern factories to combine it with low local wages.
Crucially, though, they did not hand this knowledge over to the broader host nations. They kept their blueprints and engineering standards locked tightly inside their own global value chains,
Why is that so important?
because it neutralized the dispersion force of rising wages. Normally, dropping a high-tech industry into a developing region would cause local wages to spike across the board as every company fought for the newly trained talent.
Yeah, okay.
By keeping the knowledge siloed within their own corporate ecosystems, broader local wages remained relatively low, allowing for decades of massive, rapid industrial expansion.
And this industrialization didn't just stay isolated to manufacturing hubs like China, right? It triggered a global commodity supercycle. As hundreds of millions of people saw their incomes rise, their demand for raw materials, copper, wheat, oil, cement, just skyrocketed.
Absolutely.
This pulled commodity exporting nations from Australia to Nigeria into a massive growth trajectory. For the first time in 2 centuries, the developing world began growing faster than the developed world.
When we step back, these quintessential economic mental models, comparative advantage, the agglomeration forces of new economic geography, and the balance of tasks and stages within the TOSP framework, they provide an incredibly robust architecture for understanding our modern world.
They really do.
We can trace a direct causal line from British imperial monopolies suppressing textile knowledge all the way to modern Chinese industrialization, driven by the math of offshore overshooting.
It provides clarity without needing a map that blocks out the sun, right?
Exactly.
But a mental model is only useful if it can predict what happens next. We have solved the cost of moving physical goods, triggering the first unbundling. We have largely solved the cost of moving ideas and data, triggering the second unbundling. But the sources point to a third constraint that is still actively binding the global economy.
The cost of moving people.
Exactly.
Face-to-face interaction remains incredibly expensive and time-consuming. This constraint explains why these advanced global supply chains did not spread evenly across the entire developing world. They hyper-clustered in very specific, geographically proximate nations.
Right.
Mexico became a hub for the U.S., Eastern Europe became the workshop for Germany. They centralized in locations where senior executives and specialized engineers could jump on a plane, troubleshoot a complex, unstructured problem on the factory floor, and fly back home the same day.
So it's still about human proximity.
Yes. The necessity of physical human presence is literally the gravity holding the current global economy in its shape.
So I want you, listening right now, to really mull over the implications of that final constraint. What happens to the global economy when technology inevitably shatters the necessity of moving people? Like, what if holographic telepresence, augmented reality, or advanced telerobotics achieve a level of fidelity where a handshake or a physical inspection is just no longer required?
If a lead engineer sitting in a Frankfurt office can remotely pilot a robotic diagnostic tool on an assembly line in Nairobi with zero latency, the geographic premium on proximity vanishes. What happens to the remaining safe middle-class jobs in the West that have so far relied on the necessity of physical presence?
We might be standing on the absolute edge of a third unbundling. Thank you so much for joining us on this deep dive. The next time you see a headline about a trade war, a new AI robotic startup, or a shift in global wealth, try running the facts through these mental models. You will start seeing the hidden forces moving beneath the surface of all that noise.